Okay, 9 honors kids, I'm going to develop the law of cosines and do a couple of examples. All right, number one, before I develop it, I need to teach you a fact. Okay, there's something called the unit circle. You won't be learning this until next year, but I need to tell you now, or there's going to be a part of the proof that you're not going to understand. As you go around the unit circle, now the unit circle means that the radius is 1, okay? So, as you go around the unit circle, let's say this is 1, 0, okay? Then up here, you have 0, 1, right? Etc. Now, as you go around the unit circle, these points come in the order cosine, theta, sine theta. Now, normally, when you have an equation of a circle, which you'll be learning in the spring, it's x squared plus y squared equals 1, which is the radius squared. This is the unit circle, but x is cosine and y is sine. So when you square them, cosine squared theta, or cosine of theta quantity squared, is the same thing. Sine squared theta equals 1. Okay, so you're going to need to know this fact. All right, so here we go. So I have this triangle, starting off with this. Here's theta, here's B, here's A, here's C. Okay, so just like with law of sines, we're going to start by dropping an altitude, which you know is perpendicular to the base. I'm going to call this little piece here D, this little piece E. So now I'm going to represent cosine of theta. Cosine theta is equal to D over B. So therefore, D equals B cos theta. Now, to get E, okay, E is equal to C minus D. So therefore, E is equal to C minus B cos theta. Now I'm going to call this M. Okay, the sine of theta. So these are like your steps. This is step 1. This is step 2. Okay, step 3. Sine of theta, as you know, is equal to M over B in that left triangle. So therefore M equals B sine theta. All right, so my goal, okay, is to find A. This is my goal. I'm going to find A. So we can agree that A squared equals M squared plus E squared, right? So M is B sine theta. I'm going to square that. E is C minus B cos theta. I'm going to square that. Well, B sine squared theta is just B squared sine squared theta. Okay, C minus B cos theta times C minus B cos theta. You have to do FOIL, is C squared minus BC cos theta minus BC cos theta plus B squared cosine squared theta. Okay, so I'm going back to here. So I have plus C squared minus 2 BC cos theta plus b squared cosine squared theta. That's a squared. Okay, now I can factor out the b squared, right? So I have a squared equals b squared times sine squared theta plus cosine squared theta. But from the top of the page, we know that that's just equal to 1. Plus c squared minus 2bc cos theta. Okay, so this is the law of cosines. A squared equals b squared plus c squared minus 2bc cos theta. So let's look at our original triangle. Okay, see where that works. So if you want a, all right, obviously a would be the square root of all that, as you know. This is b, right? This is c. So a squared is equal to the other two sides squared minus 2 times those two sides times the cosine of the angle between them. Now, normally, okay, if theta is 90, right? If the measure of theta is 90 degrees, then you just have the Pythagorean theorem. All right, so let's take a look at, okay, I'm going to do one where we find a side and one where we find an angle. I have b is 12. Okay, theta is 87. C is 9. A. Okay. So we need, oh, this is C. We need this angle between B and C, because otherwise we could bring the C closer to B and that would affect the size of A, right? So A squared is B squared plus C squared minus 2bc cos theta. A squared equals, okay, well, B squared is going to be 144. C squared is 81 minus 2 times 12 times 9 times cosine 87. And then you just can type this into your calculator and get the square root. So A equals the square root of 225 minus 216 times cosine 87. And then when you type that in, A is about 14.62. All right, depending on where they tell you to round to, you'll figure it out. Of course, you're in degree mode. Okay, let's use one to find an angle. Call this theta, 50, 20, 60. So here we would have 20 squared. Well, let me just write the formula out. C squared. Okay, this is my C. This is A. This is B. Okay, C squared equals A squared plus B squared minus 2AB cos theta. So A squared is going to be 60 squared plus B squared minus 2 times A times B times cos theta. Oh. Times cos theta. All right, so you do the math here. Okay, when you do the math, you're going to end up with 400 is 6,100 minus 6,000 times cos theta. Bring the 6,100 over. Divide by the negative 6,000. When you reduce this, this reduces to 19 over 20. Reduced to lowest terms. So that's cosine theta. So theta is cosine inverse of 19 divided by 20, which is about 18 degrees. Okay, so just to remind you about the ambiguous case, right? right? So law of cosines, you're usually going to use with side, angle, side, and side, side, side. So if you want to do it with side, side, angle, you have the ambiguous case. So remember before when we did law of sines, we did the ambiguous case. So when you go to try, all right, find C here, you can work it out, okay? But what's going to end up happening, all right, I'm just going to put this line. You'll have, okay, so I'm going to do, since 7 is the side that the angle's not between, I'm going to do the formula as 7 squared is 16 squared plus c squared minus 2 times 16, or 32. Okay. So times c times cosine of 30. Okay, when you go to do this, what's going to happen, all right, you'll end up with negative 207 on the left, equaling c squared minus 27.7128c. And when you try to solve that, when you try to solve for c squared with the quadratic formula, you're going to end up with a non-real answer, which makes no sense because then there's no measurement, right? All right, so that's the first one. This is no triangle. Example 1, no triangle. Okay, example 2. Here's what we had. We had this was 16, remember? This was 30. This was A is 10, but then we also had this was A is 10, right? And then this would be C in the larger triangle. This would be C in the smaller triangle. So if you go about doing this, what's going to happen, you can try doing it, you're going to end up with 2 separate triangles. Okay, so we're going to have a squared equals b squared plus c squared minus 2bc cosine theta, okay, which is going to be 30. So you're going to end up with 10 squared equaling 16 squared plus c squared minus 32c times 0.8660. All right. Now, when you go to use the quadratic formula, you know how you have plus or minus? So you're going to end up with c equals plus or minus negative, all right, it's going to be, oh, sorry. So it's going to be, you're going to end up with negative, the opposite of b. B is going to be this negative 27.7128 plus or minus, and then you're going to have this whole square root all over 2. You can try filling that in. All right, and then you can ask me in class if you guys get stuck, but you'll end up with 19.9 approximately, and you'll end up with 7.9, which are 2 separate triangles. So if someone doesn't know the ambiguous case, they're going to forget about this A. Okay, that would be the problem. They would forget about that one. So they wouldn't realize that C could equal 7.9. They would get this one, 19.9. Okay, so the third one is just only one possible solution. So you can try the one from the previous video in this situation. I'm not going to do it. I will give you the answer, though, so you can try it on your own. Okay. So what's going to happen here, when you do the quadratic formula, you'll get two answers, but one of them is going to be negative. So your final answer will be C is approximately 32.2. Go ahead and try it. And that's what's going to happen, kids. So just keep that in mind when you're doing the law of sines and the law of cosines. Keep in mind the ambiguous case. Okay, thanks. We'll be working more on this in class. Thank you.